Okay, so let's check up two homework questions. Number 13. If you read the question, it says, right here. A large part of the balloon is being filled with helium at a constant rate. After 8 seconds, there is 2.5 liters of helium in the balloon. All right, so 8 seconds, 2.5 liters. Now, I know that for my rate of change, my m is rise divided by run. So should I do 8 divided by 2.5 or 2.5 divided by 8? All right, it's a 50-50 chance. When you are on the test and you are stuck, you're only given two numbers, so you know it's either going to be this divided by this or that divided by that, right? So how you know which order is think about which one is your independent variable. Which one is your x? Jenny?
The time is always your x.
The time is always your x. That's right. So for slope, as we know, it's rise over run, which is the y divided by the x. So in this case, it's the 2.5 divided by 8. Okay, and you get 0.3125. Now that's my slope. How do I make it a rate of change? Remember yesterday, Michelle? Units. What's my unit here? Liters per second. Perfect. All right, so that's the only difference between a slope and a rate of change. You add units on. All right. So then the question asks you guys to graph it. As we said, we know that time is on the bottom, helium is on the side for my y. So after 8 seconds, it's at 2.5 liters. After 16 seconds, it's at 5 liters. So how long will it take for 10? If it's 16 seconds for 5 liters, how long is it for 10?
24.
Double that. So 16 for 5, I want for 10.
Oh, 32.
32, good job. All right, so if you were to graph it and continue to graph, you'll see that for 10 liters, it's going to take 32 seconds. So this is the graphic way. If you were to do it mathematically, you could do for 10 liters divided by 0.3125, and you'll also get 32 seconds. Okay. The question says it will burst after it's more than 10 liters. So remember what we did last chapter with the inequality? So that means the time is greater, not equal to 32. Okay. So this is just like the advanced. This is the beyond, but I think we learned enough to be able to write this as well. If on the test you just write like 32 or more than 32 seconds, it's fine. All right, but this is the fancy stuff. Okay. So when the balloon is filled for more than 32 seconds, it's gonna burst. All right. Number 14. How many of you did number 14? Good for you. Okay, so looking at this graph right here, you have car A and car B. Which one seems to be going faster? Okay, so who says car A is faster? Who says car B is faster? Good job. Why is car B faster though? Just by looking. Yeah.
It has like a higher slope.
Higher slope. What's the keyword?
Oh, I don't know, but it travels more distance in the same amount of time.
Good. Okay, travels more distance in the same amount of time.
Steeper slope.
Steeper, right? Remember, slope is a measure of steepness. So I love all those explanations. Those will get you the points. But on EQAO, if they were to use specific words, then you need to know that usually they just do steep, less steep, these terms. So you need to know that car B is faster because the line or the slope is steeper. Okay. If I just answered that, will I get full mark for this question? Take a look at the question. What am I missing? Yeah, how much? So if you read the whole question, it says by how much. Okay, so I do see 2 points right here. Okay, does that mean I can just subtract this difference and then that's how much faster it is?
No.
No, why not? Yeah?
You need to find the what's it called again? The something of change. What's it called again?
Rate of change?
The rate of
Perfect.
change and then subtract it by each other.
Excellent. You have to find the rate of change of each line individually and then subtract. So you can't just subtract the 480 from the 360 because that's only the distance difference. Okay? So you need to know, you need to do the full calculation. Alright, so for car A, I chose this point and this point. So from 0, 0 to 6 and 360, it means that they traveled 360 kilometers in 6 hours. For car B, okay, it started late, so it started 1 hour later. And then it traveled 480 in how long? It started 1 hour late. 5 hours. So 480 kilometers in 5 hours. Okay, so when you divide it, distance divided by time, you'll find your speed. So it's car A goes at 60 kilometers per hour, car B goes at 96 kilometers per hour. Okay, and then Badar, you said, what do you do with these two?
You subtract call B by call A.
Yeah, to find out how much faster it's going.
26 kilometers per hour.
Perfect. So then your therefore statement is actually, therefore car B is 36 kilometers per hour faster than car A. Okay. So at the beginning, if you just wrote me this sentence, it's good, but you forgot about all this. Okay, so make sure you read the question carefully, answer both parts of the questions. Okay. And then part B of the question says, what does the point of intersection of the two lines represent? Okay, so this point right here, the coordinate of this point is 2.5 and 150. That's the coordinate of this intersection point. Right? What do those two numbers represent? What do these two numbers represent? What do you think the intersection point represent? I put 2.5. It could be 3. It's fine. They're both at 150. Okay. Yeah, sure. Okay. So what I'm looking for is I need the units for each of this. So this 2.5 means 2.5 hours, and 150 is the 150 kilometer. So my therefore statement would be, after 2.5 hours, both cars meet at 150 kilometers away. Okay. So considering that they're both traveling at the same direction, car B, even though they left the house an hour later because they're driving so much faster, after 2.5 hours, they would have caught up to car A. Okay, so I hope car A was not on the highway, because then that will be very slow, 60 kilometers per hour. Okay. In reality, can you be driving constantly like this? No, because there's traffic lights, there's and you might be speeding, or you might be slowing down, you might be braking. Okay, so in reality, it won't, but in the word problem, we'll say that they're traveling constantly. Okay, so good job. So that was the homework from yesterday. We're gonna move on to today's lesson on correlation coefficient. Your package is actually missing 2 pages. Okay, so I'll hand this out. Okay, so this page was I don't know how, but I guess a page fell out of the photocopier or something, so it's missing this page. So correlation coefficient. Okay, it is different than slope. It's not the same thing as slope. So what correlation coefficient measure? Correlation coefficient. The symbol that we use for it is the letter R. Okay. Measures the relationship between the X and Y variables. Okay. So for example, a measure of time and distance, the measure of height and time, your X and Y variable. Okay. So in this one, if I were to draw a line, okay, notice every single point goes through the point, and so I have a correlation of R equals -1. For all of these, I need two terms to describe it. First off, if everything is on the line, we say it has a strong, all right, the correlation is very strong between the X and the Y. And then the second is the direction. Is this positive or negative? Yep. Negative. So we say this has a strong negative correlation. Okay. This one right here, -0.75. If I were to draw a line, I could still, alright, it doesn't go through every single point, okay, but I can still tell that there's some sort of relation. Okay, so this one is still pretty strong. So R equals 0.75, and we say, sorry, my bad. Sorry, this is not strong, this is perfect. Sorry. If everything is on the line, we call it perfect. Perfect, negative. All right, this one is a strong negative. Okay. So what about when R is -0.5? All right, what word would you use to describe? So this is perfect, this is strong. Not quite weak. Weak is this one. Medium, yeah. Moderate. Alright, but that's what it means. Moderate and medium means the same thing. And again, the direction is still negative. So we say it's a moderate negative. Okay, because we can draw the line, something like this. Okay, not the strongest. Okay, and then Badar, what did you say for R equals -0.25? Weak, right. It's a weak negative. So you notice every one of these, I have two description words. Okay, something like that. And when R equals 0? No correlation. Excellent. It means that there's no relationship between my X and my Y. No correlation or no relation, as long as I see that there's nothing. Okay. So in that case, how would you describe r equals 0.25? Remember, you need two words. Arvin.
Weak positive.
Weak positive. Excellent. Weak positive. Okay, and I can tell it's positive because my line now is this way. Alright. Leandro.
Moderate positive.
Moderate positive. Alright, so again, remember two words, two terms to describe. Jelani. Strong. Positive, right? See, I just said two words. And the last one, when r equals 1, Aisha?
Positive.
Aisha? Perfect positive. Yes, put up your hand, please, with r. Perfect positive. Okay, nice and easy? Alright. So your slope being 0.9 has nothing to do with the correlation being strong or weak. Okay, so the only thing that you're taking out of slope when you do with correlation coefficient is the positive or negative sign, and that's it. Okay, so let's go to the back page. Let's do the first two examples together. All right. Bella recorded the data and used her graphing calculator to find the equation for the line of best fit. She then used the correlation coefficient to determine the strength of the linear fit. Which correlation coefficient represents the strongest? All right, Leandro. 0.9, that's it. Right. What's the maximum? 1. What's the minimum?
Negative.
0. Yes, that was a tricky question. Yes. So you can still have a strong negative correlation, remember. Yeah, so okay. So there it is. That's as simple as that. Number 2, analysis of the data from the statistical study shows a linear relation in the data with a correlation coefficient of negative 0.524. Which statement best describes this? So negative 0.5. Cajun. 1, 2, 3, or 4? 4. There's a moderate negative correlation. That's right. Negative, so I know it can't be this. It can't be this. And then because negative 0.5, I know it's not strong at all. So it's moderate. Okay, and that's it. Nice and easy. I think you guys can do the rest. This looks scary right here. Okay, don't worry. I'm not gonna ask you guys to calculate the correlation coefficient because that's like calculus. Yeah, when you have to do like standard deviation and all that. So don't worry, you'll always be given an R. So here, just look at this number and you should be able to figure out the rest. Okay, so right now I want you guys to work on number 3, 4, and then on your package, if you go back to your package, it's page 5. Where is your package? Okay, so 3, 4 is there, and then if you go to page 5, you can see number 5 is here. All right. You can skip number 6. Don't worry about it. Okay, and then numbers 7, 8, and 9, you would have to graph it to see how strong or how weak the relation is. Okay. So. Oh, and then answers are right here for you to check. Okay, so what are we working on right now? Numbers 3. Actually, so 3 to 9, basically. So number Yeah, 3 to 9. Skip number 6. Alright, and make sure you need to graph number 7 to 9. Okay, plenty of time. I think this was a nice and easy lesson to understand. I will also post this video if you need anything.